Okay, it's okay. Now we'll go for the next one. Generating function for Hermite polynomial. We are going to generate the Hermite polynomials. Of course, we know this is Hn of x is nothing but your y. That's the solution of Hermite differential equation, correct? Hn of x is nothing but your y. Y is nothing but the solution of Hermite differential equation. Now we are going to generate in terms of n equals 0, n equal to 1, n equal to 2. That's called we are going to generate Hermite polynomials using this exponential term. We are going to generate the Hermite polynomial using this exponential terms. How we are going to generate, whether it is correct or not. I repeat, this is your exponential term. This is your Hermite polynomial. We are going to generate in the sense n equal to 0, 1, 2, 3. They are called generation. Generate. You are going to generate. So, h0 of x, h1 of x, h2 of x. Those are all polynomials. Polynomials of 1, polynomials of 2, something like that. So, we are going to generate the Hermite polynomials using this term. Whether it is true or not, we are going to show. Okay, that's the idea. So, for generating Hermite polynomial, this is the exponential term. e to the power 2xt minus t squared summation over n equals 0 to infinity hn of x t to the power n by n factorial. Where your hn of x, already we know about hn of x, already we have seen this one. Your hn of x is given by using power series, we know already this. Now, before that, first we will take the left hand side. E to the power 2xt minus t squared. You can separately, you can write. One is having a positive quantity, another one is having a negative quantity. So, e power x, another one is e power minus x. E power x can be written as exactly like this. We know e power x can be written as x to the power by 0 factorial plus x to the power 1 by 1 factorial goes on. We can write this as in terms of power series, in terms of summation. You write, go for r equal to 0 here, you will get the first term. Substitute r equals 1 here, you will get the second one. Okay, it goes on. So, e power x can be written in terms of power series, summation series exactly like this. Similarly, e power minus x can be written as exactly like this. E power minus x. This is plus x, this is minus x. Minus 1 to the power s, x to the power s divided by s factorial. Now we have these two terms, left hand side. One is plus term, another one is minus term. So instead of x, you have to substitute minus t squared, correct? Here it is e power minus x. Here it is e power minus t squared. So instead of x, you have to substitute minus t squared. Here it is e power plus x. Here it is e power 2xt. So instead of x, you have to substitute 2xt. So we have left hand side only this term. We know the expansion of e power x and e power minus x as it is. Now we will have to substitute accordingly. So left hand side goes with e power 2xt minus t squared. The first term will be e power plus x term. So you have to use this one. So summation over r equals 0 to infinity. Instead of x, you have to substitute 2xt. So 2xt to the power r divided by r factorial multiplied by e power minus t squared. E power minus t squared, you have to use this one. So summation over s equals 0. So we should not repeat r equals 0. So that's why I have written as another index. S equals 0 to infinity minus 1 to the power s. Instead of s, you have to substitute minus t squared, but already one minus is there. I have written minus to the power s here. For all odd numbers, it will become minus. For all even numbers, it will become plus. So t squared to the power s divided by s factorial. Now we are going to multiply these two. So we are going to multiply these two. So taking together, we have 2x to the power r, here t to the power 2s. So I can write this as 2x to the power r, t to the power r plus 2s. Minus 1 to the power s is here. Is it okay? See here, 2x to the power r, we have written 2x to the power r, t to the power r, t to the power 2s. I have written exactly like this. And r factorial, s factorial, together we can write. Similarly, I am going to substitute r plus 2s equals n. R plus 2s equals n. So this becomes r equals n minus 2s. So wherever you find r, you can substitute n minus 2s here. R is greater than or equal to 0. R equal starts from 0. So it has to go with greater than or equal to 0. If r is greater than or equal to 0, n minus 2s must be greater than or equal to 0. That's the argument. R is greater than or equal to 0. R equals n minus 2s. So n minus 2s must be greater than or equal to 0. If it is so, you just bring this term to that side. So you will get 2s less than or equal to n. So s is less than or equal to n by 2. So you can change the limit. Now you have changed the limit as s equals 0 to n by 2. And instead of r, you substitute n minus 2s. N minus 2s. Instead of r, you substitute n minus 2s. That 2s, that will cancel. You have t to the power n alone. So you have 2s to the power n minus 2s. And denominator we have one r factorial is there. Instead of r factorial, you can write n minus 2s factorial. Say n minus 2s factorial. You multiply and divide by n factorial. You multiply and divide by n factorial here. Any doubt? Now we know already this one. The solution, the Hermite polynomial, the solution of Hermite differential equation given by this. You compare this one and this one, except t to the power n by n factorial. You leave t to the power n by n factorial. Remaining term exactly equal. See here. We have taken this is from left hand side. You see here. This is we have taken from the left hand side. Left hand side. We have not touched any right hand side. We have taken only left hand side. We should get the expression for right hand side. That's the idea. So now you just leave t to the power n by n factorial out. The remaining term you compare, this will be exactly hn of x. Remaining term. So all those things except t to the power n by n factorial, remaining term you can write this as hn of x. So hn of x, t to the power n by n factorial exactly equals to left hand side. So left hand side is equal to right hand side. So this is what we can generate the Hermite polynomial using this factor. So this factor will generate Hermite polynomial. Okay, exponential term, this term e to the power 2xt minus t squared will generate the Hermite polynomial. Is it okay? Now orthogonal property. So we know about orthogonal property very well. We discussed earlier. Orthogonal means minimum there must be two functions, two variables, it will be there. When they are equal, answer will be 1. When they are not equal, answer will be 0. Kronecker delta function. Can you remember? Orthogonal function. Perpendicular. So we are going to use the same thing. So now we are going to use now n and m. See here. This is Hermite polynomial with n. This is Hermite polynomial with m. The answer is, if it is not equal to, the index is not equal to 0, answer is 0. If it is equal to, same, if it is equal, m equals n, the answer will be 2 to the power n root pi n factorial. So usually this will have 1, but here in Hermite differential equation we will have this term. Okay. So now we are going to show this one. We are going to start with the generating function. We are going to show this one. This is the orthogonal property of Hermite polynomial. Okay. The answer is 0. Then another answer is this one. We are going to use generating function. So this is your generating function of Hermite polynomial. So we know already the generating function of Hermite polynomial is given by this. So we know already. Okay. Now similar. So this is for n equals 0, but here there are two index, hn of x and hm of x. Here it is in terms of n. I can write the same thing in terms of m also. Okay, correct. But 2xt minus r squared is given by this. I am going to see here 2xt minus t squared. Here I have written as 2xr minus r squared, which is equal to hm of x. You multiply left hand side with left hand side, right hand side with right hand side. So that will give you e power 2xt minus t squared, e power 2xr minus r squared is given by this term multiplied by this term. Okay, this term multiplied by this term. Now we are not going to disturb anything on the right hand side. We are going to change only, simplify only left hand side alone. See, we are not going to change anything. Just you are going to take this one to that side, that's all. This one to that side, see. Otherwise everything will be same. Now coming to the left hand side. Left hand side I have written the same thing, okay. I have written the same thing. I have combined, I have written. See here, 2xt minus t squared, 2xr minus r squared. See, I have written exactly like this. Is it okay? Now, I can write 2xt, here 2xr. I can combine, I can write 2xt plus r. I am going to add this term e power minus t plus r squared and subtract e to the power 2 plus r squared to the left hand side. I am going to add and subtract these two terms. I am going to add this term and subtract this term. Okay, now first term 1, 2, first 3 terms. I can write this as a plus b whole squared formula. Remaining term, let it be like this. Okay, we'll see. See here, I have written the first terms here, x squared minus x squared plus 2x t plus r and t plus r whole squared, t plus r whole squared. So I am going to take this term, this term, this term and this term. Okay, 1, 2, 4th term. I have written exactly like this. Remaining term will be e power minus t square plus r squared, e power minus t plus r whole squared. Let it be like this. This term can be written as a minus b whole squared formula. See here, you have a squared, b squared minus 2ab, I have pulled minus sign out, let it be. I can write this as a minus b whole squared formula. See here, a minus b whole squared is nothing but this one. The term, let it be, you can write this as a plus b whole squared formula. You have a squared plus 2ab plus b squared formula. You can write this term as. Okay, this term let it be minus t squared minus r squared. Now I am going to integrate both sides with respect to x between the limits minus m to plus infinity. Now here I can pull here this t squared will cancel, r squared will cancel. You have e to the power 2tr. I have pulled e to the power 2tr because it doesn't contain any x. We are going to integrate with respect to x only. So this will become a constant. So e to the power 2tr. Remaining term I have kept it inside as integrants. Here I am going to integrate with respect to x minus 1 to plus infinity. Every term contains x. Hn of x, hm of x, e power minus x squared, all those things. Okay. Now I am going to evaluate this term alone. First we will evaluate, which is equal to, I am going to keep it as integral I. I am going to keep this term as t plus r, x minus t plus r equals y. I am going to keep this term as x minus t plus r as y. Differentiating will give you dx equals dy. When x equals infinity, the y, what about y? Y also will be infinity. So you substitute here x as infinity. Y also will be infinity. You substitute x as minus infinity. Y will become minus infinity. See, when you are going to change like this, x minus t plus r, you have to change the limit also. This is for the limits for x. Now we have changed the limits for y. Is it okay? This one can be replaced with y. When x equals minus infinity, y becomes minus infinity. When x equals infinity, y becomes plus infinity. So dx equals dy. You substitute here. So we will have the integral I equals e power minus y. This becomes y. So minus y dy. This is already, we know the standard integral. The answer is root pi. This is the answer for the standard integral. So this integral answer is nothing but your root pi. So we have done the answer for the integral, root pi. So we can substitute, instead of this, we can substitute root pi. See here, root pi, e to the power 2tr, root pi. The remaining term, let it be like this. We have pulled t to the power m by m factorial and t to the power n by n factorial out because it doesn't contain any x. Okay. Now, this term can be written in terms of summation, this term. Okay, root pi, let it be like this. You substitute n equal 0, you will get this. N equal to 1, you will get next term. N equal to 2, you will get the next term. So this term can be replaced with this term. So root pi, let it be like this. You have, okay, because e power x is nothing but this one. X to the power summation over x to the power n by n factorial for e power x. Instead of x, we can write 2tr. So you will have to write 2tr to the power n. So 2tr to the power is nothing but 2 to the power n, t to the power n, r to the power n. See here, divided by n factorial. Okay, now this is the orthogonal property. The first property is m is not equal to n. The second one is m equals n. Suppose when you go for m is not equal to n. So m is not equal to n, you can write exactly like this, correct? You can write m is not equal to n. You can write as it is n. When next term m is not equal to n, because it contains only n, there is no m here, so I have written m as 0. T to the power n becomes your n becomes your m, because m is not equal to n, m is different, n is different. Okay, m is not equal to n, so this is for n. We have to write for m also, so we written m also. So here it is as it is. Now you will have to compare these two. When you are going to comparing the coefficient of t to the power m, r to the power r to the power m on both sides. M is not equal to n. M is not equal to n. You will have t to the power m, r to the power m. So this becomes t to the power m, r to the power n. That becomes r to the power n. So this becomes 0 here. See, 0 here. This becomes 0. So you have 0 which is equal to this term. Okay, so you have t to the power n, here it is r to the power n. So r to the power n divided by m factorial n factorial. Suppose when m equals n, when m equals n here, so in this term, when m equals n, this becomes 2 to the power n, t to the power n, r to the power n divided by n factorial, this n factorial. Left and right hand side you will have the same term. When m equals n, m becomes n. So t to the power n, r to the power n divided by m becomes n factorial. This n factorial will cancel. Okay, now we have t to the power n, r to the power n will get cancelled. So you will have 2 to the power n root pi this n factorial. I can bring it to this side, left hand side you will have n factorial, which is equal to all those things, e to the power minus x squared h m of x h n of x dx. See here, this is what we want. 2 to the power n when m is not equal to, so m is equal to n. So now orthogonal property goes like this. When m equals n, the answer is 2 to the power n root pi n factorial. See, root pi n factorial, 2 to the power n. When m is not equal to n, already we have found it is 0. So this is the orthogonal property of Hermite polynomial. Any doubt? Okay.